We are still on data structure and algorithm. Now, what determines the type of data structure you are going to use will be what? The type of task that you want to perform. Now, if you expect to do a lot of insertion, then array is not the best. And also, if you want to delete, array is also what? Not the best. But today I'm going to show you how to delete an element from what? From an array. So still using C programming language to implement this class. So today, let's assume I declare an array like I did in the last class. For what? Say int array, and then I say 10. So this will be what? 4 bytes multiplied by what? 10. And that will be what? 40 bytes. 40 bytes of memory will be allocated. Okay? Now, let's say I create something like this. The same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 integers. So my array is this, int array 10, right? And I'm only going to assign 5 elements. So 10, 20, 30, 40, 50. Now, I want to delete this 30. Now, when I delete 30, I will have 10, 20, then dash 40, 50. Now, this is no longer an array because based on the rule, an array stores data in a contiguous space, meaning there will be no empty space between the elements, right? So if I'm deleting this, it therefore means that I have to shift this guy to this place, and then there will be a space here. So I will have to shift this guy to this place. So in real sense, deletion of an element from an array is simply the shifting of what is on the other side of that element to the position of that element. So I just need to shift this 40 to this place and then shift this 50 to this place. That is all. So this will override this, and then this will override this. So I will now have 10, 20, 40, 50. Now that is what deletion of an array, deletion of an element in an array simply would do. Now, that shifting is actually the problem. So imagine I have huge data and I have to delete at a particular position. Then I have to shift all the other elements to occupy that space. Then that is what is going to waste time. So the time complexity for that is what? 0n. So except I am going to delete this last element, then I don't have to shift anything. So that'll be what? Time complexity is what? Time constant. 0, 1. But any other position that will require me to shift, the time complexity is this. Just like insertion. If you are inserting at the end, time complexity is what? Constant time. But if you are inserting any other place other than the end, then you have to also shift to this side. So time complexity is also this. So what you want to perform will determine the type of data structure that you are going to use. So now let's write a program to do what? To delete this 30 from this place, right? I'm still going to use C language. So I have this, and this will be there. So let's write a program. Okay. So that will be include my library stdio.h, then my main function int main, right? Now inside my main function, I'm going to declare my array. So int, let's call it r, then 10. So I want to initialize it. So to initialize it, I will do my curly bracket, 10, 20, 30, 40, and 50, right? So that is initialization. I don't want to clean this. I want to use it to explain. So this is me declaring my array. So the next thing I will do is what? I'll tell you, since I declared 10, the array size is 10, and I'm supplying only this, so I have to state it. So int n equals to what? 5, meaning I'm only supplying 5 elements to the array. Then I want to delete from which position? I want to delete from this position here. So this index 2. So int, I'll call it POS position 2. So that's where I want to delete from. Okay. Now I'm also going to declare my loop counter, which is I, the guy I will use to do the traversing. Now, I haven't done this. I've declared all these variables. So n is what? 5. Position is what? 2. And then I have I here. I've not assigned anything to I yet. Sorry. I've not assigned anything to I yet. Now I want to create the instruction for the computer, right? The instruction that will enable the computer to carry out this process of shifting this to this, shifting this to this. So I'm going to use a for loop since I already know the size of my array. So I will say for I. Now I am going to put, so this is where you have to really think. So this is the instruction I'm going to write for the program to execute, for the computer to carry out this task. So I'm going to assign the position to my index. So that means I'm going to assign 2 to I. Then I will check my condition. So I is what? Less than n minus 1. So n is 5. So if the element that I'm supplying, 1, 2, 3, 4, 5. So the index will be what? 0, 1, 2, 3, 4. So that is less than 5, right? So I less than 4. So this is the same thing as saying I less than 4. Then my increment, I plus plus. Then I will close this. So let's clean this up. So now inside the body, so what do I want to do when the condition is true? So I will come here and I will say array I assign array I plus 1. Now, then I'm going to close this my for loop. So what do I want it to do? This is it. So I'm going to assign position, which is 2, to what? To I. So I is now 2. So I is pointing. So this is I pointing to this place. Then 2 is less than n minus 1. So 2 is less than 4. That is true. So I will come in. Then I'll take this place. Watch out. I is what? 2. 2 plus 1 is 3. So that becomes array 3. Calculate using the formula, calculate the memory address of this array 3. So that will bring us to what? To this place. To 40. Right? Now, when you locate it, which is 40, now assign that value to what? Array 2. You know, I is what? 2. So assign the value to array 2. So meaning we are moving this 40 to this place. So that is it. You've already deleted this by that action. Then you increment, then you encounter this. So you increment I. I becomes what? I becomes 3. So this place will become 3. Now, 3 is less than 4. That is still true. So, you know, you have shifted your I. Your I has shifted to this place. Right? So 3 is less than 4. That is true. So you will come in. I is now what? 3. 3 plus 1. That becomes 4. So array 4 which will be what? Array 4. It will calculate the memory address. Memory address will bring you to this place, which is what? This one, right? Then it's asking you to copy what is here, move it to this place. So you move it. So from here, you move it to this one, because array is now what? I is now what? 3. So you are moving it to this place. So you have moved 40 to this place, and you have now moved 50 to this place. Then you increment this I. So I now becomes 4. So 4 less than 4, that is no longer true. Then you will come out of this for loop. The moment you come out of this for loop, you have to do something. You have moved this here and moved this here. So your array element has decreased. So you have to do n minus minus. This statement is very important, because if you don't, and you now want to populate the array on the screen, you are still going to populate up to this place. Up to this place, I mean. And that will give you 50, 50. Right? So this is the logical size of the array, telling you that you have reduced the size of the array to what? From 5 to 4. N minus minus is the same thing as saying n minus 1. So 5 minus 1 is 4. Reassign it back to n. So n is now equals to what? 4. That is what this n minus minus is. So I haven't done this. We are done. We've deleted by shifting this to this and this to this. So now we want to print out the value of the array on the screen. So to do that, I'm just simply going to clean this up, and then here I will say print f array after deletion, right? Slash n. This is a new line. This n is not the same thing as this n. So meaning, once you print this out on the screen, array after deletion, go to the next line and print out the values of the arrays. So I'm going to write a for loop, but let me bring it here. So what should be under this place is what I want to write here. So for I assign 0, meaning I'm starting from here. So I less than n, right? I plus plus. So print f %d, that is format specifier. What this is simply saying is that when you go to that memory location, what you are going to see there is what? Binary digit, 0 and 1. So when you see that 0 and 1, how will you know what it represents? You have to go to integer to convert that 0 and 1 to integer in order for you to print out 10. So array I. Then you close this and you write return 0, right? Then this curly bracket, you close it here. So that is the end of my program. So once you do that, when you get to this place, you shift this guy to this place. And when you now test, it's no longer true. You come out here and you decrease this value to 4. So now you want to print out. So print f array after deletion. Then I. So now you move I becomes 0. So that will point to this place. So I is less than n. I is less than 4. N is now what? 4. So you're having n as 4. So 0 is less than 4. That is true. It will come in here. It will print f array 0. So it will calculate the address and print out the value on the screen. And that will be what? To print out 10. Then it will increment I to 1. So this will shift to this guy. Right? 1 is less than 4. It will calculate the address array what? Array 1. Right? It will calculate the address and print out the value. So the value is what? 20. Then comma. Then it will increment I. So I is now what? 2. So it will shift to this guy. Then 2 is less than 4. That is true. It will come in array 2. So array 2 will print out. Now 40 is what is here. To print out 40. Then it will increment I to 3. To 3, right? So meaning it will shift to this guy. Then 3 is less than 4. That is true. It will come in. It will print out array 3. What is inside that address? It will print out 50. 50. Then it will increment I again to what? To 4. Right? It will increment I to 4. So 4 is less than 4. That is no longer true. So it's going to skip. 4 is less than 4 is not true. So it's going to skip this body and to return to the operating system. So it has printed out 10, 20, 40, 50. So which are the arrays that you have on the screen. Now, if you didn't change this to 4, this will have been 5. And it will still print out what is in this place. Right? So that is what I want to show you in this class regarding the deletion of an element from an array. So I'll go to code block now and demonstrate this script for you to see. If you have come with me this far, don't forget to give me a thumbs up and also help to share this video so that more students will see it. So let's go to code blocks. So this is our code block, and this is the same script that I demonstrated on the board for you to see. So this is the script. Now I'm just going to execute this script for you to see what the output will be. So we are deleting. So we have 10, 20, 30, 40, 50. And I want to delete from position index 2. So 0, 1, 2. So we want to delete 30. Right? So I'm going to execute it. When I do that, see? Now look at the output. Array after deletion. So you're having 10, 20, 40, 50. Right? That is what you are seeing. Now this is what I'm saying. Let me comment this place. If I don't reduce the size of the array, I comment this place. Then I'm going to execute this array again, and you will see that the output will be what? 10, 20, 40, 50, 50. So let's execute it. So you see? 10, 20, 40, 50, 50. So meaning it deleted the 30, but it shifted. So it shifted the 40 to the position of the 30, shifted the 50 to the position of 40. But that shifting is actually copying. So you still have a copy of it, of 50 in the previous location, which is the physical location. But the array size is logical. So when we did this n minus minus, we are actually reducing the array size at the logical realm, not in the physical dimension, right? So in the physical dimension, you still have 50 stored in the memory, even though you made a copy of it to the other side to override it. So that is what I was telling you. So that is why this line is very crucial, that you must reduce the size of your array in the program, so that when it's going to read from the memory, it won't read up to the other location. So when you want to insert in that location now, it will just override that last 50. That is what I want you to understand. So the concept is you understanding the logical realm, where you actually write your program as a programmer, and then the physical realm, which is the memory, where everything is actually going to take place. So it is the responsibility of the compiler to now do that switching from that logical realm to the physical realm in terms of being able to calculate the memory address. So that is what I want you to catch in this concept. So this is what I want to show you in this class. So we will see in the next class where we'll look at linked list as a data structure. Bye-bye.